Okay.
You know what the Zach said?
Yeah.
Yeah.
I'll share what I can when
What chapter is the majority of?
Greeks. What are quadratics? Who did well at quadratics last year?
I don't think we did it, did we? Right. We didn't do quadratics. Yes, we
You didn't?
did.
What shape makes quadratics?
Umbrella. Parallel.
Oh, umbrella? What's the actual word for
P.
parabola?
Yeah.
Okay, cool. All right. So 3.2 starts off, we've already done something called the null factor law. I've got it here in gibberish with A's and B's. Who would like to explain in your own words to the class what does that mean? In
Something times 0 equals 0.
something times something equals 0.
Yeah.
Good, you've done the first part. What's the second part of the null factor law?
Therefore, one of them has to be 0 and the other whatever it wants to be.
Almost correct. You are right though. One of them can be 0 or both can be 0. Okay. So let's just quickly do example 1. 3x squared minus 5x equals 2. Do you see a 0 in this question here? Okay. What do we need to do to incorporate a null factor law? How do we get a 0 in here?
-2.
We minus 2. Gabe wants to take that over to the other side. Now the 0 appears. Okay. Now we want to solve. We want to find out what our x's are equal to.
We put x's together, right?
Yeah, so we've got x's. Now I'm going to give you a clue. We're going to divide them into factors. This is not factors. These are factors. Factors multiply with each other. And we know there's 2 in here.
Isn't it plus 1 and times the others?
Yeah, so it depends on what you want. If I see a 3x squared, what's the only combination when I cut it between the 2 brackets? A 1 and a 3. Okay, so I'm going to start with a 3 here. There's really no other way to do that, to split that up. So we need to figure out what 2 numbers multiply to -2, but then they add. But when we multiply them out, it adds to the middle term.
It's got a times equal to.
Yeah, so it's got, yeah. So what combination can we have? If I have, what can I put in the first one? What 2 numbers multiply to -2?
-2 and 1.
-2 and 1. Let's try this. Okay. This and this make this, but let's figure it out. In the middle is a -2x. On the side, 3x times 1 is a 3x. If I put them together,
is there a plus 1?
It's a plus x. Did that equal the middle term?
You're just going to switch the
Okay, it didn't. So sometimes you're going to have to experiment on your rough piece of paper. So that's not going to work. Does anyone know what would work?
No.
Plus 1 and -2.
Plus 1 and -2. Let's try that. Okay, let's look in the middle. In the middle is a 1x. On the side is a
-5x.
a minus.
Oh.
3 times 2 is 8.
Oh, that was minus. Oh, sorry. Yeah.
Equals
5x.
1 take away.
5x.
Is that right, Zane?
Yes.
We got it. Well done, Zane.
That's so good.
Okay. But we're not done yet. So we proved that that works. What's the key word in the question?
Solve.
We solve. What do I do now?
D plus 5x, right? 0.
One of
No.
the things in the brackets must equal 0.
That's right.
Null factor law.
The null factor law states that the first something can be the 0, or the second something will be the 0 because it's 0. So they have, for our answer to be a 0, this could be the 0, or this could be the 0, or both can be the 0, because 0 times 0 is 0. So we've got two equations to work. How do I solve for x from here? What do I do first? Minus 1, and we divided by 3. Over here, we plus 2. Guess what? If x equals 2, if I put 2 in here, 2 take away 2? 0. That makes the whole thing go to 0. Likewise, if I put a negative 1/3 into here, I can put them in both. But this guy on the left, what's 3 times negative third?
1.
Negative 1. But then you plus 1.
Negative third. Oh, so 0 as well.
0 again.
So both equals 0.
So both. So we've got two answers. If x equals 10, this doesn't make 0. But once it's either a 2 or a negative third, this whole equation goes down to 0. All right. Any questions with this? Now, we're going to lead up to that. I just want to see, do people know where this is leading to in a graph? Okay. We'll answer that question in a second. All right. What's the next question? Given that x equals 3 and x equals negative 3 are the zeros of a quadratic, form its linear factors and expand the product of these factors. A lot of words in here. I'm just going to simplify what this means. Does anyone know what we're trying to do? Yeah.
Make a reading equation and then expand it.
Yeah. We're going to make a quadratic, we're going to make a quadratic equation and expand it. Okay. Right now they've given you an answer of x equals 3. And that creates a 0 in our equation. But if we want to go to a factor, we want to take a step back, like we did our backtracking just before. What I mean by this, opposite of plus 3 is?
3.
Opposite of minus 3 is? Just like before, we've taken a step backwards and we've created factors that create the 0. Okay? It says here, form its linear factors and expand the product. So why is this a linear factor?
If you have the gradient and the y-intercept.
Yeah, good. Good, doesn't it? You've got a gradient and a y-intercept. It's a power of 1. Linear. It's a line. This also a line. That's why this gibberish here means linear factors. So we've got two factors now. It says expand the product. What does the word product mean, Amrita? Product. Multiply. So we're just going to multiply these two. That's all it's asking us to do. Factor 1. Factor 2. This really is a question that's going in reverse from the other one.
So it is the same question?
No, it's not. Okay. But then, have we answered the question?
No.
What haven't we done? Yeah. We haven't expanded. Okay. What do you notice about these factors? Okay.
Difference bracket squared.
It's a dots. Thanks, guys. One's to add, one's to subtract. Therefore, when we expand it, x equals 8x squared minus 3 squared. That's the difference of perfect squares equation. Okay. Which becomes x squared minus 9. Okay.
The end to that whole equation.
Yeah, it is.
It's so odd.
Okay. All right. Let's go to the next question.
You've been uploading these to YouTube?
Yeah, I have.
Did you email us the link to your YouTube?
Yes.
Did I?
Yep.
Once you get into one link, you can get to the others. Okay. Over here, example 2. Look at it carefully. What is it?
Difference of two squares.
Difference of 2 squares again. It stops. It just looks a bit different. First square is 49 a square.
Yeah. Yeah.
Okay, so we want to solve this. Therefore, how am I going to solve this one here? There's 2 ways to do it actually. Let's use difference of perfect squares. So if I have a squared minus b squared, what's the equivalent of a squared minus b squared? It's
A minus B minus A B plus B.
good. So this is our a and this is our b. What do I write first? So I have a minus in here and a plus in here.
3x plus
3x plus 2 is the first one. That's our a.
7.
There's 7 and a 7 in here. Okay. And what's this equation really equal to?
0.
Once you've established your 0, what are we going to do with our factors? What's the conclusion, Jesse? Okay. That's all right. Okay.
One of both are going to equal 0.
Exactly. So let's write that down. The first guy can be the 0, or
Second.
the second guy, or girl. Whatever you want. 2 take away 7.
-5.
-5. Okay. What did I do with the -5?
Plus
What did I do with it? Times by 3.
divided by 3.
Divide by 3. Go over here. 3x plus 9.
9.
What's 9 on the other side?
3.
So -9. And it becomes -3 when we do the reverse. Okay. If this was an equation, what are these?
Coordinates.
Of what? X intercepts. Okay, we're going to get there. We're going to get. Okay, who knows the other way of doing this one? There is another way.
No. Because it's fair in brackets.
We do. Oh, sort of.
Do we?
Not quite. You can, but no. Expanding won't help us. Okay. If I have 1x here and I expand it, how many x's do I have, Perry?
3.
2. I've got 2. I'm in trouble. I have 2 x's. I want to keep 1x. I don't want to expand it. But you can backtrack straight away. Can I do that?
Yeah.
What's the operation on the other side for the next step? We do. Okay.
Wouldn't it be 7?
Becomes 7. Becomes 7.
Okay.
But equals 7. Take away 2. Now This is the lolly question today. There's a mistake in here before we keep going.
Plus 2 select.
No.
Go square root 2.
No.
Hmm.
Okay.
Oh wait, no. Which step is the mistake?
It's not no.
Where's the mistake?
Okay. I haven't included something here.
Plus or minus seven?
Yes. Thank you, Emily. When you do a square root,
How do you do that?
every time you do a square root, you must put a plus and minus.
How do you do that?
Okay. Does anyone know why?
It could be -7 or +7.
You need to account for negative answers or a possibility that they're both positive. Okay. Okay, so plus minus 7 in there. Therefore, we can now separate. We can have a positive 7 take away 2 or a negative 7 take away 2. So 3x is equal to 5 or
3x equal to -9.
good. X can equal to 5 on what? And x equal to -9 on 3, which is?
-3.
-3, which is the same. You can go both ways.
Oh, I like this. I like
Whatever comes naturally to
I
you.
like the second way. Yeah, I like the second way.
Guys, we've got one more question before our first break, okay? We're doing well.
So you've been teaching well today.
Oh, thanks.
Okay.
You've been listening well today.
Thanks.
Okay.
That was so fun. I'd watch about Hudson a lot. So something was like. Yeah, I was thinking, I don't think I did.
Yeah.
Yeah. I don't know if I'm right.
Last one before our first break. It says to solve this.
That's so good. Speed plus 7.
It is pretty gross.
What was the equation for a quadratic again?
X to the power 2.
So it's yx to the power 2 plus
Oh, yeah. So it must have an x squared in it and then
everything else.
anything else. Okay.
Well, I remember that. Cool.
Thanks.
Thanks.
I actually don't have to scroll to the. Okay. This is the last example. Now, 6x4 minus 19x squared minus 7. I know this is not a quadratic. Okay. Does anyone know, by the way, what do we call anything to power 4? It also starts with Q.
A cubit.
Good try. You're very close.
The quad receptive.
You're very close.
Quad.
It's a quartic.
Oh.
It's called a quartic, X power 4. All right. Now, there is a bit of a trick in this comes with experience. So in this case here, we have a problem with X to the power 4. We've got to use a tool to help us to keep going along. Now, I'm going to... Does anyone have any ideas?
Plus 7 first.
Okay. Not quite. Okay.
I was going to just say that you can still use the null factor law with it.
Yes, you can. We can still use the null factor law, but how?
It's enough actually.
How? I'm going to show you. Okay, we're dealing with quadratics here, so I'm going to let a new letter equal a quadratic. Okay, so just bear with me. Is this the same as this?
Yeah.
Can everyone see now that the x squared has now appeared in both?
Yeah.
I can now use our, I don't know what you call it. I can now do that squared because this bracket is this u.
I understand.
What's this going to become?
Nothing new.
Good. Now we're going to pretend they're x's that they're u's, okay? Now this can break up now. and it might take a bit of experience. What's a good possibility of 6? What two numbers?
2 and 3.
Okay, 2 and 3. Okay, 3 and 2. Instead of x's, what are we dealing with? Used. Okay. Now, what possible numbers multiply to -7?
3.
None, 7.
1 and 7.
Or no.
So you need to decide where does the 1 go and where does the 7 go.
How do you know?
It's a lot by trial and error. Okay.
Well, it's just 1 then.
Okay.
Okay.
You could have had the 7 here and the 1 here. This could be wrong, but
It looks.
it is right.
How do you know it's right though?
It's just by when you multiply it out, does it equal to the middle term?
Yeah.
And we're going to test that out. 1 times 2u is
2.
2u. 3u times -7,
Negative 21.
does it equal -19?
I get it.
So we know we're right. If you did it and you didn't get a -19u, you didn't backtrack. Try again. Last step. Okay. Now we need to solve this. What's 3u plus 1 going to equal to?
Or you.
0.
0.
Wait, what?
What's 2u minus 7 going to equal to?
0.
0. As we did with our x's and u's, we do the same thing. 3u is equal to?
Negative.
U1. U is equal to?
Negative.
Equal 3. 2u
7.
is a 7. U is a 7 on 2. But we've introduced something that wasn't in the question. Got to change it back to x. What's u? What was u before? X squared. What is... Oh, here, yeah, x squared. Okay. Nathan, how do I get rid of a square? Square root. When I do a square root, I
Have to have a plus 1.
well done. Do the same over here. Okay, we're not there yet. Let's just tackle this guy on the right. Okay. So we have a positive and a negative. Can we do this?
Yeah.
You can do that with certs.
That's just so much more tricky. Can we just leave it like that? Or do you have to do that?
They might, because they might ask you to rationalize. What do we times by?
Negative.
Oh, 2 squared. Let's go root 2.
Root 2 and? Root 2. What's root 7 times root 2 as a set?
14.
So root 14. You just
2.
multiply on 2. Okay. Now, remember, what's wrong with this?
You can't square root.
You cannot square root a negative number. Okay, think about it.
So does it mean it has to be negative?
It means you can't
No,
accept the
That
answer.
makes sense. You can't make it negative square root.
That's right. No matter what you do, guys, listen up. If you want to square a number, like 3 times 3, it's a positive 9. Even with a negative, it will still be positive. Okay? Does that make sense? We cannot square root a negative number. I know if I do a square root of 9, it's a 3. But I can't do a square root of a negative 9. It does not exist. It does not exist.
that in weird or so.
Okay?
Oh, use
We say can't accept the answer. So we reject. We reject.
But if I get that, I'm just going to think I'm wrong.
Only if you see a square root of a negative.
So what do we do once we've retracted? I dare say I'm better.
Then the only possible answer. Last one before we take a break. We only have how many answers in
Two.
we've got two. A positive root 40 on 2 and a negative root 40 on 2.
Yeah.
We could have had 4. Because quartics look like this.
Don't do it.
It's just a parabola movement.
That's a quartic.
The W.
It's like a W.
Get it? W. You can probably U.
But can anyone, well, to have it with only 2 intercepts, because we're talking about intercepts here.
If you only have it with 2 intercepts, it's just a flat parabola.
Yeah. Yes. Yes. Not quite. I know where you go. Okay. Good. Amrita?
6x.
Where? Oh, here. Yeah. 2 and 2 and 4. What was the other 2? What do you mean?
Like on the 6x squared.
Yeah. Yeah. This one here.
Where? 100.
That's the U now.
Oh, this is the U now.
The other 2.
The other 2 what?
On the outside of the house.
It's on it.
That becomes
This one?
into it.
That becomes into it.
Yeah, it becomes
Yeah, that's why it's U2.
U equals x squared.
And then
Squared would be
Yeah, yeah. So
that's there.
x 2 times 2 is 8.
Yeah, but like when like later on, it just
That goes. See the two. See
Yeah.
the square.
It
Of
doesn't come into play.
you should just send
We'll have a discussion. I'll talk to you in a break. Okay. Now, 2 answers here. Quartics can do this, by the way. Okay, so they stretch. It's still a quartic, but there's 2 intercepts and the other intercepts never happen. That's why we've only got 2. Gabe was talking about sometimes a quartic looks like this, and it just hits one point.
Wait, well, we have to.
Like someone's bum is sitting on a bench. It will just be flat. Okay, that can happen too. All right.
It's so real, bro.
Now I just want to. Yeah.